Alright everybody, this is PlayStation Repair Augusta back again. This is the third video of the day, which was supposed to be a 3-part series. However, it looks like it's going to have to be a 4-part series, and that last part will be for tomorrow. Unfortunately, the day just kind of slides by without knowing where it all goes, and I'm not doing a 4th video now at 10:30 starting this one. This one hopefully won't be extremely long. But what we're doing is we're coming back to, in the last video, we were going through this Ethernet controller and the Ethernet controller. And we had replaced the IC chip, which is here, just to recap. This IC chip is usually where you have an issue when you have a short. However, I'm starting to wonder if that chip was bad. I'll have to probe out and test the other one. All we could test is that we had shorts on the lines. Where they were originating from, we don't know because we were connected to the lines that have shorts. But it turns out we did, and you do sometimes have this. We had shorts inside of this guy. And there is an array of, let's see if we can show these. Now this is not the one that actually came out of this, but this is one that is from the same board. And you can see there, this, not your standard way that a USB gets hooked up. So, I mean, PlayStation has done some things there to kind of help in terms of that continuity of signal, and there's probably some transient protection in there somehow. I want to say that's more about stabilizing that signal than it is for ESD or a surge protection, which would utilize more of like TVS diodes. However, one way or another, I mean, this is where I've got to look more into this. I would like to understand a little bit more how something like this shorts, because it's, I mean, you can just look at it and you can tell that's a confusing setup. You don't see that inside of every Ethernet port. In fact, I mean, this wasn't the way that they were set up in the one we pulled the other day out of a modem for a customer that had, actually this customer, this is his board, this was his modem, where this doesn't have those in it. One of them did have it had that, it has this, which I've seen these protections on there before. I'm not sure, I don't think that's a MOV. I believe that's something else. I haven't yet decided if I want to tear that open and take a look. And if you're wondering how people come up with these repairs, that is literally it. Tear stuff apart, make it messy, probably ruin some things, and then eventually you figure stuff out. I mean, that's literally how you learn when you're trying to reverse engineer something that a manufacturer tells you nothing about. And also, you know, I haven't done this repair yet. I haven't said, you know what, I just am going to do it secretly on the back end. And this is, in fact, the board that I showed the signature on earlier. I stuck this in there just for, I guess you can call it dramatic effect, because, boom, look at that. She is not attached. Now, you could call it, where are all my dynamite effects there? I've just, wow, that is a slippery wicket there. And there's, no matter how much space you have, there's never enough space on the table. You just seem, it just disappeared behind me is all. This is the one that we're going to use. This is what's going in there. Where are we at? Here we are. Alright, so that's the one we're going to use. This is the one that I pried to death and forced to come out and took off the shielding so that I could look inside and see what all components are going to go short. And then this is the one that actually came off this board. And technically, could it be reused if it didn't have a short in it? Yeah, maybe, but would you? Would you really want to use that? Looks like a waxy asshole. That's garbage now. But it goes to show a great point. Now this is, with all the tools that I have, a vacuum desoldering pump, a quick hot air station that gets hot, super hot, and I struggled to remove that. And that is because of, I mean, look at all, this is a shield. I mean, that is a beast of a shield. It is on there once it's in there. And then it goes these through holes, and the ground plane, look at this ground plane. All right, that is a massive ground plane. And I wanted to use the tools that I have to remove it here at this level. And they failed miserably. Even with professional grade tools, it just did not want to come out. Now, the way that I would normally do this and the way that I would recommend doing it, but most people don't have these tools, so I wanted to see if it was a headache for me, and it was. So if you need to remove this and you're working with hot air and a desoldering braid, or a even if you have a vacuum desoldering pump, you're going to struggle with this. Go to somebody that has the setup, or if you're interested in being a micro soldering repair professional, and I mean, or if you want to salvage parts from boards, the way that I was able to successfully desolder this and remove it from the board was taking it over to my reflow bench and putting it over a bed of IR plates, which heat this entire board up to, what do we take it to? I go in stages, but basically I eventually get it to a temp that ranges between 180 and 200 degrees Celsius, and then an arm comes in and goes down, and there's another IR plate there. I don't have a hot air top, I have an IR top. To be honest with you, I think I want to switch back to a hot air top. It's been so long since I used one, I'm going to need to try it out to see if I want to go back that route. But I think it is more effective than the IR top, because you can get too much saturation through areas that you don't when you have that penetrating heat. But from the bottom, I want that IR heat. I want it to penetrate from the bottom up to the top, and then come in with either your IR and your hot air if you're trying to remove this. And that top heater, it again goes in stages, but it eventually wiggles its way on up to, I think mine, I have it set, it will go much hotter, but then you're killing boards. But I have it set to top out at about 240 degrees Celsius. This loosened up at about 225, and I was able to just take a pry tool and just pop it right on out of there. And then I had to do a little bit of cleanup so that I got my ends cleaned up, and now it just slides in and out real nice and neat, and we can pop that in and out. And this is a good port. This is one that is not shorted. Came from a donor board, because I don't think you could find this exact match somewhere else. And I'm not sure if what they got going on with those coils in the back is really necessary, but your best bet is to pull this from another board or look online to find somebody that has a surplus of them that you can maybe buy them off from at a decent price. Now that that has been addressed and we've kind of caught everybody up to speed, what we want to do is just go ahead and do some probing. And if you remember from the previous video, it must be, again, that my multimeter needed to be replaced, because I actually tested that beforehand and had shorts, and then I'm pretty sure that when I replaced this, or when I pulled it off, I checked, but maybe I didn't. Maybe I'm mistaking it from one of the other boards that I pulled donor parts from. But I thought I had checked this and that I got a no short, and then put the new one back on, and I start getting a short. And right now, we get, and let's put this in alignment here so that you can see what's going on. Well, that isn't going to work, is it? Let's get this over. You don't need to see the port anymore. Let's go back to, alright, so when we tap together, we're beeping, that's continuity mode. We want to test for continuity, and now this is not attached. But because of the way they have this configured, we're going to get continuity on these lines, these pairs, I should say. But right now, none of them are. And that's because we had a short inside of this as well. And more than likely, if we had a short here, we probably had them here as well. But I'm going to test that original chip just to see, because that will actually help indicate that if our short is solely inside of this, and that original chip was 100% good, then our shock did not travel from HDMI through some back channel and then up through this. It actually more than likely originated this way and then hit that chip and then stopped, or never even made it to the chip. Well, I'm pretty sure it would have had to have made it to the chip because these were all shorted. They weren't just blocked off. So this is where what we want to make sure is that these aren't short to ground, and that this pair is not short to this pair or this pair or this pair. Pairs should not be shorted together in this configuration. But the way that PlayStation has it rigged is that they are short to their own pair. Well, they are in continuity with their own pair. And that is because of that little wire array that they have going on with the, what would you call that? What's the word? Stuff evades me at times, and this is one of those things that I'm calling stuff. So it'll pop in my brain in a moment, and I will share it, but until then, we're just... inductor. Told you it wouldn't be long. So that's some type of inductor configuration, as obviously wire wrapped around a magnetic ferrite core coil. So something is going on there that is stabilizing, amplifying, conditioning. Maybe that's a better word. It's conditioning the signal. And then maybe in some way this deals with transients and acts as like a TVS. That's what I want to research more into. When I say research, I mean I'm going to go scour the web and maybe ask some people that are smarter than me what their thoughts are on it. Why would Sony do what they did? And if we had a schematic, we could simply reference that. But again, those aren't shared with the public. So we have to either know it already or figure it out or ask somebody who's already figured it out. So tonight, all we're going to do for this last video is we're going to put this on. We're going to make sure that when we solder all of those pins together, that we then do not get continuity between all of these points. And I've actually already checked it underneath, and from my test, we're not going to. Now again, maybe my meter is well past needing to, so if we get surprised and shocked here at the end, I'm probably going to be quite angry because it's, again, going to be a mission to get this thing back off. But once we finish that up, we'll have one last thing for the night, and then that will be the end of it. And that one thing is that I did get my package, and I received my Arctic Silver thermal paste from Amazon. And this is a third-party distributor that places their items directly with Amazon. And we're going to open it up and see, because the price point doesn't make sense, if it's bull or if it's legit. And my vote is, it's complete and utter bullshit. If you disagree, if you think that things can be had for cheaper than the manufacturer sells them to wholesalers for on Amazon, feel free to jump in and make a comment. If you're not watching live, feel free to write that comment in. Go for it. And I'm sitting here trying to break off some solder, and I don't even have the heat turned on. Alright, so what we want to do is get this nice and wicked up. And we're just going to go ahead and do this 100. That's the disadvantage to this camera being where it is. I end up having to reach for things that are in front of it. and I make you stare at my wrist in giganticize depending on how big the screen is you're watching on. Alright, so I'm going to support from underneath. We've got a tinned tip with flux down on the board. I cleaned it on my little brass sponge. And I like to tin my pins first because I want to make sure that they're right before I go and align the mounting pins. Well, I should say I like to tin my data pins. They're all pins. And as you can see, I had to put so much into getting these off that I had to scrape away a lot of that layer. But I'm not going to recoat them. I'm just going to put some solder down. Do like the paint guy. Just gonna do a nice little dab of solder right here. What's that guy's name again? Oh yeah, Bob Ross. Bob Ross. Over here, we're just gonna make a solder bird. Just a happy bird. I was watching something on TV that said, I think he volunteered, or if he did get paid, it was like nothing, but I want to say he got nothing from it. No royalties, no anything. Now, once we have these pins where they need to be, you know what? Really should have tested this, and this is where you can tell it's late. Before you go and do your mounting pins, we should test everything, because at least at that point, those mounting pins are connected to that ground, and they're the hardest to get off out of everything that is there. And we want to do this. We want to test it. Alright, so we got our continuity. Again, just to show. No punches pulled. Alright, so that has a signal. You son of a... Why are we getting... But we don't have signal here. So what do we have going on now? Alright, so now you get to see something interesting. So now we've got a pair in continuity with another pair. Let's do this. We're going to double check this. And this is just kind of ragtag thrown together. Alright. Alright, so this is another board. This is a board where okay, maybe that is correct. We're not shorted all the way across anymore. But we have continuity between 4 pins. But not between those. See, no continuity, continuity, continuity. And maybe earlier I was looking at a SAA board and maybe it's slightly different. I don't think that it is, and I just obviously have been having some issues with the multimeter. But before, we had a short across all pins, all 8 lines, I should say. Was that even in there? Did you even see that? Let's raise it up a little bit. We'll make it clear for you. And then, all right, so now you can certainly see that. So continuity, continuity, no continuity, and no continuity. Well, continuity over here, but no continuity with this over here. And that doesn't matter how we shake it, but as soon as we get into this little quad set, we have continuity again. So that gets tricky, and again, to be honest with you, I really it doesn't make a frack ton of sense to me. It seems odd from what I would think, but obviously there's some really weird stuff going on inside of these guys. And in fact, just to confirm whatever weirdness we got, let's go ahead and take another look here. Let's take a look at this guy. Alright, so you're going to really get to see this now. We've got 4 pins for every one, but I think that there's a join somewhere in here. And in fact, if we look down through this, we can see that there's a line running up here, but it actually it looks like it's connecting over here. So if we probe this, all right, those 4 are together. But see, they're not here, and they're not. Those 4 are not. And if we tap these 4, and we go here, and we go here, but we're not there. So this 4 correlates to these 2. The next 4 correlates to the next 2. And then we throw in another curve. We've got the center pin, which is ground, but it's not grounded there. Where are you grounded at? I probably tore all your grounding away. Yeah, all your grounding has been removed. So somewhere in here, there's a connection to ground. But we're going to ignore you for now. So those correlate to these 4, but not to this one. And then those 2 correlate to these 4, but not the others. So this shows that every 2 are where they need to be. You malaka. It really wants me to take it back off, doesn't it? So we knew before we had no continuity across them. Now, if we have 2 pairs sharing continuity, are any of them short to ground? And I basically just have my red probe on ground, this probe here, this probe here. Another question is, are we being trolled by a low impedance that gives us are we getting full short? Now we're at 2, 1, 9, 1, 8, 1, blah, blah, blah. You know, I'm curious. All right, so we may still not finish this today, and this is when repairs get interesting. I mean, maybe there is a problem with this, but I think what's best to do at this point is we're going to remove a possibility, and we're going to do that by taking away the the chip, because that's actually, this chip, this controller, is easier for me to remove than this big guy. What I'm tapping with my hot air, this guy. That's how much I hate this guy and like this guy. Okay, so we want to now turn on hot air, and we're going to pre-warm with some low heat. And watch how much easier this one comes off now after we've gotten rid of, and in fact, I'm pretty sure that other chip was bad. Remember when in the previous video where we took it off, it did not want to come out, even at high heat, high airflow, just laying into it with some heat, and it still did not want to remove itself. That is a early warning sign of a shorted component, where it's stuck on the board. It basically got hot and went critical, especially with a surge spike. It almost does like a tack weld that just seems to have this impenetrable bite force to it, that no matter how crazy you get with heat, it just seems like you can't fix it. And I'm not even going to bother putting flex on this, because we just got done installing this sucker. So, and you can even see where it's got a little something underneath. And if you watched the video earlier, or if you haven't, go back and watch it, and you will see the difference in how easy that was to pull off versus what we had to deal with before. So now that that's been removed, the question is do we still have shorts across the two different pairs? Which is very possible with the fact that we're connected to that chip. If that chip had something bad going on it, whether it was a chip itself or maybe there was a bridge underneath we couldn't see. I doubt highly that was the case, but anything is possible. And hopefully you saw that earlier. I might not have even been on it with the camera. I'm horrible about that. Alright, so continuity. We're definitely getting that from that device. It just doesn't make sense to me. And sometimes you just kind of got to roll with the punches and try it out. That's probably the best thing to do. But I'm in a state of curiosity here where I want to know. Alright, so suck you and suck you. Alright, so what I want to know is why would you bridge? We got 2 pins, and 2 pins. Unless they somehow cross. And let's do this. Actually, we've got 4 and 4 on this one. Okay, now we're getting signal. I think I was getting trolled by my multimeter earlier. That one shows 4 and 4. If this was right all along and I have removed this just for shits and giggles, I would be so pissed at myself. meaning that our chip was our only problem to begin with, and we've already replaced that. But again, something about this math does not add up. It doesn't compute. Because when we look at it here, I mean, this is the raw, the gritty. All right, check it out. We've got gold. Where's this gold? Gold to gold. Are we on the other side? Okay, well, wait a minute. Okay. We may have some really funky stuff going on here. Let's check that out this way. Let's look at it like this. Well, screw you pins. Came in just to fulfill my promise of making this video. And this Ethernet is wanting to make a fool of me. Now that's interesting. This is different from how I tested it on a Slim, but yet it's also similar. Alright, so we got gold to gold. We got red to red. We got green. Green to green. Red to red. Somehow that green and red does commingle. And then we got green to green here. Alright, so our pairs are this way. We got green to green, gold to gold, red to red, green to green. There is no cross in between. But yet these sides, do we have front side and back side here? Okay, so this may be an isolated Cat5. Well, that would then answer our question that yes, our short did come from the other side. Alright, so we know that's going to happen. Alright, this is when you really want to know, you go this route. You take out your snips. And you dissect. So sometimes you just have to know. And I'm just going to start tearing away at it until this shell breaks away for me without, hopefully, destroying parts I need. This is where I need like a public service announcement that says, do not try this at home. Your Ethernet will not work. after performing these steps. Oh, that is bonded in there, and I'm tearing shit up. Okay, so that is not done for yet. Ooh, but what is underneath? That is interesting. What do we have? Oh, you're a Malacca. Alright, I wasn't expecting that underbelly there, but yet, there it is. So well, that makes sense because those are our, these go like this. Okay, that makes complete sense. I'm an idiot. Luckily, though, we still have test points there. What I want to do is free this PCB so that I can see everything. I want that omnipotent vision. Alright. I want to know exactly what is going on. Oh, look at this. We got more stuff going on underneath. So, woo, piece of candy. Alright, so we do have some protection under here. Oopsie. Get the freak out of the way. So I'm pretty sure that addresses all of it. And so we should be able to figure out what the heck is going on at this stage. Alright, so these guys go into our front side. That's what these dudes are doing here. And these guys make up our back side, which makes sense. Alright, so front side, back side, coils in between, and a 75 ohm resistor array, which is this, 75R0. A capacitor of some capacitance, who knows what. Alright, I see where that goes. I don't know where those go. They more likely come up through the top there. Blah, 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 yada, yada, yada. Okay, so the weird thing is that when we test and probe this, even with this one off, we didn't get quad pairs, I did not think. And it just doesn't make sense that we would have a quad pair when these are wired up for twosies. So, you know what? I'm probably going to pull a couple of more of these tomorrow and yet again have to come back to this because I don't want to be here all night. I don't want to keep people up all night. We know the problem is not our chip. I am going to go ahead and pull up the data sheet on this chip, and I'm going to go ahead and probe it before I go and stick one on there, because the last thing I want to do is have to deal with one extra new issue. And before we start shoving metal down underneath, this is definitely not the way to go about that. I should have moved this out of the way. I'm going to have to also now check and make sure that I don't have any debris up underneath that SMD. I will blow that out with compressed air. Like I said, I'm giving you these videos raw, so you're going to see crazy crap like this happen. You're going to see some of those moments where, man, where sometimes you just feel like slamming a board up against the wall. And this is probably one of those. Because this, I mean, again, I keep saying it, but it really doesn't. It does not make sense. If you're an engineer and you know what the heck is going on here and you can explain this, I can understand pairs being shorted together, but continuity between two pairs, I mean, that just, it does not compute with me. I am trained and schooled in network topology, and this does not make sense to me. Everything I know tells me that should not be the case, but I'm probing it and I'm finding that it is the case on multiple instances. And now either all of these have the same issue, which I know they don't, because actually one of these that I pulled, and so I might just have to trust that there are people out there with way more knowledge on this subject than I do, and they say that it works, and so therefore it does, because maybe this is the case, because this board Ethernet works on, and I'm pretty sure I got that brother-sister love that's going on here. These mated pairs. It was a weird way to say that, wasn't it? Alright, so yeah, sick of you trying to confuse me there. So we get it there as well. I'm starting to think that this is a natural state, but having those data lines in continuity like that, I mean, just straight continuity, that's not even a low impedance. What do we get? We got 5, we're down to 4, we're down to 3, we're down to 2. I mean, I know there is a case where you can use 4 lines, and you're just half plexing your signal, so you're getting a lower overall throughput, and that is possible. But 2 lines, I don't think that even meets standards, and you're going to have collision of all kinds of crazy sorts if you got continuity between 2 different pairs. Yeah, I'm confused here. Okay, so what we're going to do is when you get this way, it's best to just kind of step back, let your brain kind of simmer on it, and once it's, to use the food analogies, marinated in all that thought, you usually have a moment of clarity in there, and something goes aha. So I think that's what's best to do at this moment. I'll probably do some reading. I'm definitely not pulling out an old textbook, but there's something that I'm missing here, and you know what? Let's just, for hoops and giggles, I'm trying to limit my use of other words so that I really don't care about the monetization side of it, but I did have a customer yesterday that their kid was with them, and we were talking about the YouTube videos, and they wanted to watch it. And I had to let their parent know that, hey, you know, it's not always kid-friendly. So for that reason, I try to control myself, but I don't think that it's ever going to be possible. People that know me know that I was in the Air Force, in the military, I was going to say, but not a sailor. But I damn sure know how to curse like one. um, it's going to happen. It's going to slip out. I can't control myself. They're too much a part of me, and I'm too lazy to bleep anything. And I do all live videos because I'm lazy and don't want to have to edit. So there's never going to be the opportunity for me to filter to appease everybody. So, like I said, I don't think we should have to. And even for those people that have lost monetization over it, I think that is just, it's crap. Advertisers shouldn't care in today's age. You know what? Or Google shouldn't care. And maybe it's because I guess they mix through all their advertising, but how easy would it be for them to put a filter between advertisers that don't give a crap if you say whatever? They go, you know what? We're an open-ended platform, and we will let you throw our advertisement on any old phrase, and then Google can say, okay, we'll do that. Rather than saying, you know what, we're going to accommodate the prudes in the world. And that's the problem, is that if you keep accommodating that, then it'll continue to be the standard. And I said before, the words only have as much power as you give them. When I say all the four-letter words that I like to say, it doesn't mean anything to me. And if it hurts somebody out in public when I say it, I'm not apologetic. The only reason I do try to accommodate for the younger side is if they want to watch it, that's good for me. It's good for business. So in that sense, I make a modicum of an effort. If they're watching the videos, they may share it. The purpose of these videos, in addition to just allowing me to rant and joke around and pretend like I'm not talking to myself, is that they allow me the opportunity to reach out and just show the capability to my local market. Because there's not many people that do this type of repair work. For the most part, I'm the only one in my area. And if you are one of the others that do it, then great for you. There are quite a few that they advertise that they do the work, and then it ends up coming to me. And I have made arrangements with a few retailers that, they call it their service. They send it to me, and I repair it. One of them even tells their customers that they send it to me. And he does all the tear down, reassembly, all of that good stuff, and then just sends me the board. It makes my life easier. It makes his life easier because he doesn't have to learn how to do every single one of these repairs or go through the hours of diagnostic troubleshooting like what's going on right now. So this is what we did earlier, and we have removed the leaded flux or leaded solder. Now we got the lead-free solder. Now we've got leaded. And it is going to be much easier to work with. Oh, that's so much nicer. Okay, this tool actually does work on this board when it's not. Man, they don't use solder. I don't know what these manufacturers are buying, but that stuff is cement. It does not melt. It does not stay liquidous. It has like no hold time on temperature. As soon as you take the tip off of it, it is back to solid. You can thrust hot air down inside of it. You could whisper sweet things to it if you wanted to. And it's going to look at you in the face and tell you to get bent. Alright, so now this is actually the ground pin, and you can see it did not want to cooperate. It did not want to release any of what it had to offer. Luckily, that one did right. And no, I lied, they did not. They still, but we're not actually hitting the bottom there. So I can't really blame the tip. And now here's a little inside secret. Alright, so we're going to take soldering iron. Check this out. We're going to apply heat to this pad here. I don't know if that's what these were designed for. I doubt highly that they were. They're more than likely probe points so that you can test. And then we're going to use those to double down on our heat. That is actually stuck to the side there. That's why they say you have to rub it. I need that song playing as I do this. Man, this is so unnatural. I mean, this could be easier. I don't know what it is about the design of this board, but it's like it said one-time install only, please. Maybe I could slide in there, but no. And see, if I would not had juiced up those mounting pins, we'd be almost out of the woods right now. But because I wasn't thinking, I applied solder to them, and now I'm paying for it. So what we're going to try to do is manipulate this into doing what we want it to do, and we're going to do that by applying pressure as we heat up these contacts and let it kind of try to work itself out. We don't want to put too much pressure because we'll start to flex that board. So we want it to be natural, but we also have to assist. And my heat just dropped. We need to be at max for this to work. I should probably change out the tip to something larger. The bigger it is, the better. But Alright. And now this sucker does not want to go any further. Apply a little cheater's heat. To get really lucky, it would force that solder to run the length. And it would basically remove itself from the gap because it just... I'm trying not to burn this. And this is why the IR is better. Notice that that was never burned when I used the infrared heat. It wasn't until I put hot air on it that now we're starting to melt that casing. But it's not past what I would consider a workable tolerance. Or a usable tolerance. Okay, not a good idea to shove my hand into the hot air. Right, and so as much of a pain as that was nothing compared to when it had the manufacturer's original lead-free cement that they use. Alright, so what we've done now is we've removed that socket. And take a look. This is the problem. Take a look at this. You've got... Don't go out, light. I need you. Alright, so you see that? How it's gray? I mean, it should be shinier than that. I just put massive amounts of heat on it. Maybe could have used a little bit of flux, but it really shouldn't have. But the problem is that because it's losing heat so fast as you're applying heat to it, that you're basically causing it to just dry itself out. And those joints become brittle, and when they get dry like that, I don't know if you saw that earlier. Okay, yes, you can definitely see that. When they get dry like that, that's a sign that they're going to be hard to work with. And so this is what happens when you have a major ground plane and you're having to fight against rapid cooling with rapid heat. You just get these brittle, dry joints that just become seized up. And when it's lead-free, those joints get even worse, and that's what I like to call lead-free cement instead of just being solder. Alright, so, we finally lost enough heat. I mean, I just want to test these straight up on the device. Got nothing there because I turned it off. This is our last little test for today. Like I said, I'm going to have to go and stew on this, and then I'm going to come back and watch it end up being that I'm in diode mode here. Alright, continuity. So all of these are paired up, which to me is a little odd. This is ground though. Check this out. No, what the friggity frack? Because there is a pin here that solder is connected to, and it just runs straight out the back and then does that little chunkity junk there. What else do we got here? I mean, potentially this is just how it's supposed to be, but just something doesn't feel right about it. If you know what is going on when it's in this configuration, feel free to share. But for me, I am baffled. Other than just maybe the amount of heat that it took to remove this. And like I said, I used the IR, so I doubt highly that that is the case. Unless there's something super sneaky, super tricky up under there that requires a very special heat profile to work with. And again, I just think, I mean, other than it being booby-trapped, which who knows with manufacturers nowadays, it just doesn't seem like it makes sense either. I do want to know where the freak is. I mean, you're grounded there. Why would you not? I guess they're just doing a ground plane on a circuit and then obviously being joined through here for ground. Is it that? No, because these are already. Okay. Super weird. That would basically have on this line, the way that I see that is we're taking 4 twisted pairs and making them into 2 pairs because there's continuity between them, and that does not seem right. I will be back on this subject tomorrow. I do have some other repairs to attend to, but like I said, we got to get this customer taken care of. If nothing else, we're going to do a raw test with one that's paired up like this, if that's what's necessary, and we're going to see if we get our Ethernet back. We're going to figure out exactly how this sucker is supposed to work, because right now it's just wanting to troll the crap out of me. So I would say my normal say of I hope you learned something today, but I don't think I learned anything at the moment other than how to get frustrated from a PS4. Eventually we're going to crack this code, but until then we're going to have to tuck our tail between our legs and say tonight was nothing more than a frustration. If you have any questions, comments, info that may be helpful with what we're working on in this video, feel free to post it into it. I, by all means, don't say that I am the absolute authority. There are certainly those out there that have had channels like this that have been doing the PlayStations certainly longer than I have. So maybe they can chime in and contribute and say, here's what you're not understanding. But I have been doing this for long enough to know that something just doesn't feel quite right here, and that we should be getting a different reading than what we are. So again, if you've got a comment, if you've got a thought, even if you've never worked on this before and you'd like to share something, post it in the comment section. I will be checking it even after this repair is long done and over with. I will go back and follow up. So if you have those questions, let me know. If you like the video and want to see more, go ahead and hit that thumbs up and the subscribe. If you'd like to see something different other than what we've already got posted, put that into the comment section and that video may become a reality. It's been fun, as much fun as pulling the hair out of my head can be, but until tomorrow, take care and see you all then.